Today we are discussing the topic of geometry, one of the most important topics in CSIR-NET Part A section. It is important, but the problem is if your mathematical background is not that good, some of the questions will appear difficult for you. I am not saying that I can make all the questions look simple for you, because some questions need your thorough understanding of math or your geometrical understanding. So, I will try to give you insights of almost all the things, but you can, at the time of exam, you can decide which question is easy for you. That questions you can concentrate more, because in every topic there will be difficult questions also, simple questions also. In geometry section also, some questions seems to be difficult if your basic geometry understanding is less. The main problem is geometry is so wide. Even if we learn theory of geometry, that is not enough. There are more theory remaining, because it can be of plane geometry, solid geometry, or circular geometry, or three-dimensional shape geometry. Many things are there. So I will try to give you a summary of all the important things that have asked in previous CSIR-NET exam from geometry. Geometry itself can be divided into 3 chapters actually. This chapter and the next 2 chapters are geometrical chapter. One chapter is actually geometry, that means plane geometry and solid geometry, 2 things. And second chapter is area and volume related to geometry. So area, volume related topics are called mensuration. So geometry, mensuration and distance and direction, these are the 3 geometrical chapters. We will be also discussing this as 3 different chapters itself. So today we are starting this first topic, geometry. That itself we may need 2 lectures or 3 lectures. And the third topic is distance and direction. But theory regarding all these 3 we will summarize in today's class. First of all, geometrical shapes you should understand. Geometrical shapes. In this flashcard I have summarized it. You can go through it. First of all, geometry topic questions can come mainly from plane geometry also and solid geometry also. Plane geometry means 2-dimensional geometry. All these things, polygons, all are 2-dimensional things itself. So 2-dimensional geometry is given here. So 2D geometry, 3D geometry, and some questions come from coordinate geometry also. That means coordinate system, XY axis. So coordinate geometry also, but the number of questions came from coordinate geometry is less. Anyway, we will discuss this in detail. First of all, let's get familiarized with the polygons, so that at the time of exam, if there is any of these polygons comes, you have no confusion about what is that and how many angles are there and what is the length of, what is the value of each angle, what can be the side length, all those things we will discuss. First thing, triangle. Triangle is the basic polygon, or a polygon with 3 sides. Yeah, a polygon should have at least 3 sides. 3 or more sides should be there for a polygon. So a triangle have 3 sides and 3 angles obviously. And mainly there are 3 types of triangle. 3 types of triangle. One is called isosceles triangle. Isosceles triangle, 2 sides will be equal. Moreover, 2 angles also will be equal. These 2 angles will be equal. And in previous CSIR-NET, there was questions related to it, whether you know whether 2 angles, which 2 angles are equal. Depending on that, you will be able to answer that question. I will show you all those questions. For example, if these 2 sides are equal, if this is one equal side, the opposite angle of that side will be equal to, this is the next equal side, means opposite angle of that. These 2 will be equal. That means if the picture is like this, if these 2 are equal sides, these 2 are opposite angles. So opposite angles in an isosceles triangle for the equal sides will be equal. That property please remember. And equilateral triangle, all the angles are equal. I think all of you remember it. All the 3 sides are also equal, all the 3 angles are also equal for an equilateral triangle. Now, right triangle and equilateral triangle, all the angles will be equal and all the angles will be equal to 60 degree also. That is because of the angle sum property. Angle sum property is another 60 degree for each of the angles for equilateral only. For isosceles, two angles equal, the third angle may be different. But anyway, whichever triangle, sum of interior angles will be 180 degree. Due to that, we are saying that equilateral triangle, each angle will be 60 degree. So that 60 plus 60 plus 60 is 180. And for right triangle, one angle exactly should be 90 degree. Other two angles can be anything. But here also angle sum properties should satisfy. So if this is 90, if this is A and this is B, A plus B should be equal to 90 for sure. And that was needed in one of the question. So anyway, this much things you should understand about triangles. And triangle, there is another important property. Look at this question, look at this scenario. If this is X, this is Y, this is Z. For triangle, X plus Y should compulsorily be greater than Z. X plus Y should be strictly greater than Z. Y plus Z should be strictly greater than X. X plus Z should be strictly greater than Y. This also you have learned in school days, that sum of two sides should be greater than the remaining side. For example, if I am drawing 3 as one side and 4 as another side, another side as 8. That triangle is impossible to happen. Why it is impossible? Because 3 plus 4 is 7. 7 is not greater than 8. That is impossible. Why it is impossible? Because for triangle, if you think from the perspective, this is one angle theta. That theta should be less than 180, na? Because sum of interior angle is 180 means it cannot, one angle cannot be 180. One angle should be less than 180 only. If it is 180, what is the meaning? That is a straight line, that is not a triangle, that is a straight line. For example, 3 length, 4 length. So that is a straight line whose total length will be 7 centimeter. Yeah, if it is straight line also it is 7 centimeter, then how the other third side can be 8 centimeter? That is why sum of two sides should be clearly greater than third side. I was just illustrating, if it is not greater, what will happen wrong? So anyway, that is clear, I guess. That also is one thing that you should remember from school day. Again, all the things I am teaching you today is actually school day math itself, but I am taking what all was asked in previous NET exam or what all normally asked in competitive exam related to geometry. So that is triangle. This much things is clear, I guess. Now going for other quadrilaterals. Quadrilateral means a polygon with 4 sides is called a quadrilateral. So all these are quadrilaterals. Square, rectangle, parallelogram, all these are quadrilaterals. For those quadrilaterals, the properties or sum of interior angles will be equal. For all quadrilaterals, quad means 4. That means 4-sided shapes, sum of interior angles will be 360. That is the second thing you should understand. For square, rectangle, parallelogram, rhombus, trapezium, which all are four-sided shapes or 4-angled shapes, for them their sum of interior angle will be 360. Just like triangle it is 180, here it is 360. That also remember, that will be needed in some questions. So 360 degree. Square you know, rectangle you know, parallelogram also I am sure that you know. Rhombus, parallelogram almost same, just a parallelogram with all the sides equal are called rhombus. Yeah, I will just familiarize that with you all, so that if anyone have forgotten it, let you remember. Square, you know the shape, all the sides should be equal. Rectangle, opposite side should be equal, all the angles should be equal to 90. Or simply speaking, square is just a special rectangle, and this point is needed in one of the question, that all squares are subset of rectangle. Square is just a subset of rectangle, or square is just a special rectangle. What is rectangle? A parallelogram whose opposite sides are equal, a parallelogram whose all angles are 90 is called rectangle. And for that rectangle, if all the sides are equal, that is a square. That means rectangle is just a subset of parallelogram, square is just a subset of rectangle. And rhombus is what? Rhombus is a parallelogram whose all sides are equal. Just like the relation between square and rectangle, rhombus and parallelogram, we can establish that the opposite sides are parallelogram means opposite sides are parallel, opposite sides are equal. So that is a rhombus. Now trapezium. Trapezium is like a rooftop. All day rooftops are of this shape. Now, two sides are parallel, other two sides are equal but not parallel, they are like this. So that is a trapezium. And there was a question which is only checking whether you know what is a trapezium. I will show you that question today itself. Then they are the four-sided shapes. All those four-sided shapes, sum of interior angle is 360. Keep that also in mind. So four-sided shapes also done. Now five-sided shape, pentagon. Pentagon means this is a pentagon. Pentagon or any polygon can be regular or irregular. A regular means four-sided shapes are called quadrilateral. In the four-sided shapes, quadrilaterals, square is a regular quadrilateral. Why regular quadrilateral? Regular means if all the sides and angles are equal, that is called regular. Pentagon also it can be regular or not regular. Regular means if all the sides and all the angles are equal, that is called a regular polygon. Equilateral triangle is a regular triangle, we can say. But these are not regular. Square is a regular quadrilateral. So that keep in mind what is pentagon and what is hexagon. Hexa means 6. So 6 gun. Heptagon means 7 gun. Octagon means 8 gun. And you should know the sum of interior angles. That will help you in many questions. And if you think that that is too much to learn, don't learn all of that. Just learn this formula I have given here. That will give you sum of interior angles for any polygon whose side is given. I will just explain. N minus 2 into 180 degree. What does that formula mean? For example, if it is a triangle, n is 3. N means number of sides. Number of sides and number of angles are equal. So number of sides or number of angles 3. 3 minus 2 into 180 degree. For triangle, it is giving you 3 minus 2 into 180 degree, which is 180 itself. That is how this 180 can be obtained. For any quadrilateral like square, rectangle, parallelogram, anything, it will be 4 minus 2 into 180 degree because all of them have sides 4 in number. So 4 minus 2 to 2 into 180 degree, 360 degree. That is how 360 comes. Now for a pentagon, 5 minus 2 into 180 degree. 5 minus 2 is 3, 3 into 180, 540. And hexagon, what is hexagon? 6. 6 gun, that means 6 minus 2 into 180 degree. 6 minus 2 is 4, 4 into 180 degree is going to be 720 and so on. So that is how these values can be easily obtained. So try to learn this. Side number minus 2 into 180 will be sum of interior angles. If you know sum of interior angles, each angle of a regular polygon can be obtained by that. For example, if you know that hexagon sum of angle is 720, if it's a regular hexagon, all the angles are equal. 6 angles are there, so each angle will be 720 by 6. 720 by 6 is 120. That is how you can obtain that each angle will be 120. Same like equilateral triangle, sum of interior angle is 180 means each angle will be 60 degree. Same idea. So if you know sum of interior angles, that is always good. So remember it. So that is about normal polygons. Now there is a special polygon called circle. I hope all of you remember circle theorem. So I have just summarized the circle theorems that is needed for CSIR-NET exam. Especially the last 3 theorems, please learn it. Last 3 theorems, the angle subtended by the arc at the center of the circle is twice the angle subtended by an arc at the circumference. For example, if you start this angle will be double of this angle. That is the meaning. Angle subtended by an arc at the center means if P and Q is fixed, from P and Q, if you are drawing a line to O, the center, and drawing a line to the circumference anywhere in the circumference, those two angles have a relation. The central angle will be double of the circumference angle. That is what we are understanding. That is the third property. Now the fourth property, angle subtended by an arc in the same segment. Arc means this is the arc. Arc in the same segment are equal. That means if P and Q are the endpoints of that arc, if you draw angles to the circumference, whichever way you draw, all those angles are going to be equal. That is what the fourth property is saying. Now the fifth property is angle subtended by a semicircle is a right triangle. That means semicircle means the endpoints of the diameter, if you are joining, that angle will be 90 degree. So these three property, learn it. Now we will just show you some questions related to this, and after that we will come back. Basic polygons and questions related to that. This is one question. All these are CSIR-NET problems itself. Please make an attempt. Following is the odd one out. These odd one out problem, be very careful, because there can be many perspectives in which you can find the odd one out. So here, as it is a polygon, the main two things you know is sides and angles. Na? So we will start with sides and angles. So for isosceles, square, regular, hexagon, rectangle. Yeah, I told you regular means all the sides and all the angles are equal. Square, you know, all the angles are equal. Rectangle, all the angles are equal. Isosceles triangle, all the angles are not equal. That means with respect to angle, you can easily say that isosceles triangle is the odd one out. Some of you may be thinking that you can think from the perspective of sides. No, with respect to sides, if you think the problem is rectangle also all the sides are not equal. Isosceles triangle also all the sides are not equal. So that will not discriminate it. There will not be one odd one. There will be more than one odd ones. So that is why sides is not the criteria we are expecting. Angles is the criteria. So isosceles triangle is the odd one out. Just checking this question, this CSIR-NET problem is just checking whether you remember these things. Whether you remember what is isosceles, what is regular, hexagon, etc. And I told you just to check whether you know what is a trapezium. This was a CSIR-NET problem asked, I think, in 2013. Make an attempt with this question. Three identical equilateral triangle plates of side 5 cm are placed together such that they form a trapezium. So you have to imagine how three equilateral triangles can be placed to form a trapezium. For that, first you should know what is a trapezium, which we discussed already now. So this trapezium shape you have to make with three equilateral triangles. Yeah, definitely you can do like this: 1, 2 and 3. That means if this is one equilateral triangle with all the side 5 cm, another, if you just invert this and join them like this, this will give you a trapezium. So that is the idea. Now what is the question? What is the length of the longer of the two parallel sides? I told you two sides for an equilateral triangle which are parallel. Longer of the equilateral sides means this is the longer one, and that will be formed by the base of two equilateral triangles. So 5 plus 5, 10 will be the answer. Straightforward question, 10 is the answer in this question. So option C, 10 will be the right answer. I hope all of you are clear about this. If so, I will explain a question regarding the circle theorems. There were two questions regarding this directly asked. So we will start with this question, June 2019 CSIR-NET problem, and I will explain that theorem in detail with this question, so that if there is any ambiguity, that can be cleared now. Yeah, I will clarify that theorem that I have shown. You should understand it clearly. This 220 degree half will not be the answer. 110 is wrong, because this theorem says angle subtended by an arc at the center means that angle will be this smaller angle. Smaller angle means this angle, not this angle. This is called reflex angle. Angle subtending means joining it to the center, what angle you are getting like this. So that will be the smaller angle. That means that is not what the question is giving here. Question is giving 220, that is this big angle. So to find this AOB smaller angle, you have to do 360 degree minus 220 degree. Why? Because total angle is 360, angle around a point is 360. That is one thing you learned in school days. So definitely if this is 220, remaining will be 360 minus 220 degree. 360 minus 220 degree is 140 degree. 140 degree will be this angle O or AOB angle. So we got central angle now. Now you can apply. We haven't got central angle earlier. Now only we got that central angle is 140. Now this angle's half will be angle Q. And that is what the question is asking. AQB is what? Option A, 70 degree. As a matter of fact, angle P also will be 70 degree because we learned the other property that angles subtended by an arc at the same segment are equal. All these angles are equal. From P and Q, if you are drawing angles in different directions, all of them will be equal if you are drawing to the circumference. That is why all these are going to be 70. If you draw like this, that will also be 70. All of them will be 70. Very simple question, but very basic things. If you are not clear, you will get a wrong answer. So option A, 70 degrees is the answer. Let's see one more question from this topic which was asked in December 2017 CSIR-NET problem. They have just twisted the question or twisted the image to confuse you, that's all. This picture, if you draw straight, it will be something like this. This is the picture given. If you draw straight means it will be something like this itself. This angle is given 90 degree. This is 90 degree. Then what is this angle? That is a question, and that is what we just learned, that it will be half of 90 degree, 45 degree. I will explain a little bit more. Question says that 3/4 of a circle are given, are shown in the figure. That means these are 3/4. AO and AB, OA and OB, these two are radius. So definitely this angle will be 90 degree because question says they are perpendicular to each other. So this is 90 degree means what is this angle? This angle is an angle drawn to the circumference. Yeah, this is also same. This is also same. All these are going to be equal as we learn the property. So all these are going to be 45 degrees. So the answer is option D. Because of the theorem we learned, angle subtended at the center of the circle is double the angle subtended at the circumference of the circle. This, all these are going to be 45 degree. Yeah, if the question was asking this, you would have thought about the theorem easily, but they have just drawn it in sideways just to confuse you, and the image is also tilted a little bit to confuse you. If the picture was like this, then everyone would have remembered that theorem, but they haven't done that because they want you to think more, or they want to make sure that you understand the idea correctly. So anyway, 45 degree will be the answer. Now about sum of interior angles and all I discussed a little bit. With that you can do this question easily. All of you make an attempt. December 2018 CSIR-NET problem this is. So I will explain about tiling idea. What is tiling and what is a requirement for tiling a surface. Yeah, here if you are very thorough, or if you have observed tiling in different places, that itself can give you the idea which of the options are the odd one out. Because in the context of tiling a plane surface means which of the following four shapes you cannot use for tiling properly. Tiling properly means without any gap you have to tile it, or without breaking the tile you have to tile it. For which of the options that is not possible, that is what we are trying to find. Maybe you have seen regular hexagon tiling in a lot of places. For example, if you see the interlocking in road or interlocking in our houses, regular hexagon tiling is very common. Square and rectangular tiling is very common inside the homes or inside the rooms or everywhere. And equilateral triangle tiling we are not seeing much, but that is also possible. I will explain this theory first. First of all, regular hexagon tiling you can do like this. Sorry, equilateral triangle tiling you can do like this, because this will cover the region, or this will cover a plane without leaving any gap. And why is it so? Because one angle of equilateral triangle is 60 degree. If you arrange 6 equilateral triangle like this, you can cover a region without any gap in between. because 60 plus 60 plus 60 plus 60 plus 60 plus 60, 6 into 60 is 360 degree. That central angle 360 degree should be covered. Na? Yeah, obviously this will be repeated. I am just taking one sample of it and showing you. This will be repeated like this. This will also be 360. Or simply speaking, for a tiling to be proper, with the particular angle of that shape, you should be able to cover 360 degree by arranging them how many number of times you want. Here 6 equilateral triangles are needed because 6 into 60 is 360 degree. Or in other words, we can say a tiling is possible if the given polygon, each angle are a factor of 360 degree. That way you can say. For example, if it is square, each angle is 90 degree. So tiling is possible because 90 plus 90 plus 90 plus 90, if you add up, you are getting 360. Yeah. Then again repeating front, top, left, right, front, top, bottom, everywhere you can do the same. So definitely that tiling is also possible because 90 is a factor of 360. That is the reason. Now the third one, regular hexagon, that is where the central angle you should know. I told you to learn sum of interior angles of a triangle because of this itself. When it is a pentagon, you may not be remembering it is 108. But if you learn that common formula n minus 2 into 180 degree, which is for sum of interior angles. Penta means 5. So it is 5 minus 2 into 180 degree. 5 minus 2 into 180 means 3 into 180, 540 degree. So 540 degree is sum of angles, and there are 5 angles for a pentagon. So 540 by 5. 540 by 5, 108 degree. That is how 108 can be obtained. So 108 degree will be the one angle for a regular pentagon. So definitely 108, 108, 108 added any number of times, you cannot get a 360. That's a problem. Because 108, 108, 108, if you add 3 times, you will get 324. If you add 4 times, you will get more than 360. So that is why this tiling is impossible, because there is gap in between. 324 remaining, 36 degree remaining. You cannot cover 36 degree with a polygon. Because this is a regular polygon, that is why. If it is not regular pentagon, the tiling is totally possible. For example, this is also a pentagon. With this pentagon, tiling is totally possible because you can join like this, you can invert this tile, you can invert this tile, and that kind of tiling you can see also. But there it is 120, 120, 120, because in that case you are making this as 90, this is 90. So that means for that pentagon, all the angles are not equal. But question clearly says, with a regular pentagon, can you tile the surface or not? That is the question. So with regular pentagon, you cannot tile, because regular pentagon, each angle is 108 degree. 108 is not a factor of 360. That is why option C is the correct answer, because it is the odd one out. With regular pentagon, you cannot tile properly. There will be gaps in between. And then fourth option, regular hexagon, just for your further understanding I am showing. Regular hexagon is totally possible, because regular hexagon sum of interior angle is n minus 2 into 180 degree, which is 6 minus 2, that is 4 into 180 degree. Hexa means 6, so 6 minus 2, 4. 4 into 180 degree is 720 degree. 720 degree is the sum of interior angles of a hexagon, means one angle will be 720 by 6. 720 by 6 is 120 degree. That means each angle is 120 degree. Each angle is 120 means 120, 120, 120 will be equal to 360. Or simply speaking, 120 is a factor of 360. So we can say hexagonal tiling is possible. Yeah, this is just one example. You can repeat it any number of times. There will not be any gap if you are using regular hexagon. Again, if you are not using regular hexagon, there is possibility that the tiling is not proper. But with regular hexagon, you can clearly tile a surface easily. So that is the idea about tiling. Tiling related questions, 2 more questions are there. So I will show one more question in this class. So in this question, option C, regular pentagon is the answer, because 108 degree is each angle for a pentagon, not for a regular pentagon, and 108 is not a factor of 360 degree. If so, let's see another question on the same type another question. December 2015 this question came. All of you make an attempt. Okay, Harshida have given the perspective of physics. Yeah, I think physics students can relate to it easily, I think. After the previous question, this question is very obvious now. One is required to tile a plane with congruent regular polygons. Congruent means same size, similar triangles. So regular polygons, just like previous question here, all the polygons are regular. That is what the question says. Regular 6 gun means hexagon, 8 gun means octagon, 10 gun means decagon, and 12 gun means dodecagon. Yeah, the name does not matter. So 12 sided, 6 sided, 8 sided, 10 sided, 12 sided. With which of the following polygon is possible? With which of the following polygon is this possible means, with 6 gun it is already possible. We already discussed about it. This question we already discussed it now. In the previous question we discussed why with 6 gun or hexagon. 6 gun and hexagon are exactly same. If anyone is confused regarding that, avoid the confusion. 6 gun and hexagon are exactly same. For a 6 gun and hexagon, why it is possible? As we discussed, each angle is 120 degree. 120, 120, 120 added is 360 degrees. So hexagonal tiling or regular hexagonal tiling is totally possible. That is why option A is the answer. But let's see why the other tiling is not possible. Let's go back to the picture we had regarding each polygons. Yeah, for an octagon, this is an octagon. For an octagon, what is the problem? 1080 is the sum of interior angles using this formula, n minus 2 into 180 degree. N minus 2 into 180 degree means 8 minus 2, 6 into 180 degree, 1080. But 8 angles are there, so 1080 by 8. 1080 by 8 is going to be 135. 135 degree will be the angle, each angle. 135 angle if you add up, 135 angle if you are placing like this, here you cannot create a 360 degree with 135's combination, because 135 is not a factor. 135 into 2 is 270, 135 into 3 is more than 360. So 135 is not a factor. That is why octagonal tiling is not possible, or regular octagonal tiling is not possible. Now for 10 gun, what is the problem? For 10 gun, the problem is, if it is 10 gun, 10 minus 2, 8 into 1080, 8 into 1080 is going to be, 8 into, one second, I'll take a different color. 8 into n minus 2 into 180 degree means 8 into 180 degree. 8 into 180 degree is going to be 1440. That will be the sum of interior angles. And one angle is going to be 144. That 144 is also not going to be a factor, na? That is why. So for a 12 gun, what is the problem? For a 12 gun, each angle will be, first you can find the sum of interior angles, 10 into 180 degree. 10 into 180 degree is 1800. Each angle will be 1800 by 12. 1800 by 12 is going to be 150 degree. Each angle is going to be 150. 150 is not a factor of 360. So that is why these options are not possible. Anyway, once we learned last question, we already understood 6 gun is possible. But I was explaining why other polygons are not possible. 6 gun is possible because each angle for a 6 gun is 120 degree. Each angle for an 8 gun is going to be 135 degree. That is why it is impossible, because 135 not a factor of 360. 10 gun not possible because 144 degree is each angle, regular 10 gun, and this is not possible because 150 is not a factor of 360. So that is why option A is the only correct answer.